so far are really good. Okay, so let's share shapes and let's go back down to 3D shapes. Like I said, there's quite a lot. You could have done circles, we could have done volume, there's perimeter and area. That's all kind of information to do with shapes. Net is shape. So if you look all the way down here, we've always got shape and space. But I thought if I go straight to the one that actually says shape in its title, I will scroll down a little bit. If we get time to jump into another one, we absolutely will. Let me just grab this, grab my keyboard, move that out of the way. That's going on the back of my screen, but that's okay. Right. So name the three-dimensional shape involved. Right. Name the three dimensions involving in calculating volume. And the way I think of that, I'm hoping you can see my screen. The way I think of 3D, obviously, is three-dimensional. But when we put the measurements at the end, we've always got the 3 there, so we know that it's been a 3D shape. If it's a flat shape, two-dimensional, we have exactly as it says there, 2 dimensions. So when we're completing a volume question, it's important that we put the little 3 on there. Quite often, if it's online, it'll have you just to write the numbering. The digits will already be written, but sometimes it'll say, "Can you show me the digits you're using or the measurement you're using, whether you're using millimeters, centimeters, or meters?" So let's draw on that. So we've got length, and if we think about, well, we can look at that shape right below. That's the wind. Then we've got the width. I always think of that as being my garden. So that gives you the plan of my garden. But then if I try and put height on there, I'm thinking of a house. So if we're looking at the area of a shape, we're looking from above and we can see everything in it, like your garden, you're going to go for a walk. It's a play area. If we're looking at volume, we're looking at something that's got upwards as well. So it's the volume of my house, the volume of a Pyrex dish, the volume of a container in your fridge, things like that. So we're looking at 3 dimensions. So that would be the answer to that question. Next one, which object is bigger? By looking at those measurements here, we should be able to straight away tell that this one, oh my gosh, I wasn't going to write on there. I can write on there, but it just means it goes all funny. So question 2. Can I have a paper? Can I have a paper? Whoa. Can I have a paper? So I just saw that message pop up there and it disappeared. Can I have a paper with written forms on the exam? Okay, so no, but if I show you, right, let me get this revision guide. So there's nothing stopping you, and I'm not saying write every single formula down as soon as you get into the exam, because that could take some time. But if you're thinking about the key ones that you need, for example, like volume, 3D, but think of it as being 3. You'll have 3 measurements on your shape. But if I show you, let me grab what I would say. So over the last, I wouldn't say 10 years. I've been at SCL for nearly 11 years, but I've only actually been doing the functional skills probably for about 9 years. So over the last 9 years, it seems longer than that, but over the last 9 years, I've kind of created, that's the wrong topic, wrong folder, sorry. I've created a little guide. It's not the definitive guide to pass functional skills. It's not the definitive guide that everything is in here will appear in your exam, but it's a guide where I'd say lots of it, if you remember how to do it, will come up in your exam. So like if you see, for example, the distance, speed, time triangle, if you remember that D comes on top, then it doesn't matter which way around those two go at the bottom. And again, we'll move on to distance and speed and time, or if you've done those questions or you're going to do those questions on Atom. And what I would say, as long as D's on top, it makes no difference which round they go, because D is the big one. And if you want to find the speed, you divide it by time. And if you want to find the time, you divide by speed. So it doesn't matter which way around they go at the bottom, as long as you know that distance goes on top and then the other two go underneath. And likewise, when we did percentages yesterday, that word I said no, so new value and old value, little things like that, shorter ways of remembering things. And I'm going to show you something else. You won't need to remember any of these in your exam. These are all going to be there for you. So it'll say Steve's filling up his petrol tank, oh, is in America, so he's going to be using gallons, not liters. Can you tell me how much it's going to be? So you'll get the conversions for you. It'll say, 1 gallon equals, or 1 liter equals. And likewise with weight conversions, length conversions, distance, you'll always get the equivalent written in there for you, like a little key. So you don't have to remember any of the conversions. Obviously how to do them, but not you won't have to remember the digits. What else do we have to remember? With circles, my advice would be, if you can remember those top three, then there's no issues whatsoever with the other ones. This one pops up, the surface area of a cylinder, it pops up, but if you think about a cylinder, I always think of it as being a packet of Rolos. I measure my top part of my Rolo packet, I measure my bottom part of my Rolo packet, then I take my wrapper off my Rolo packet, and it's a flat rectangle, so then I can measure that part. So the surface area of a cylinder is not as difficult as what you think. It's literally the wrapper of a packet of Rolos and the two end bits added together. But if you could, you'll need to remember just the surface, the circumference of a circle and the area of a circle, because after that, the rest can be worked out again, like the volume of a cylinder. If you worked out the flat part on top, like the top, and again, I use food. The tube of Pringles, I've got the top of my tube of Pringles. It's that little clear bit that you put on top. That's the area of my lid. If I want to find out how much volume's in it, I just times it by, I've worked out my area of my lid, I just times it by how big. I've got a big tube of Pringles, or I've got a little tube of Pringles. So I just do my area of my circle on top, and then the depth of my, or the height of my cylinder. So those, if you remember those two at the top, the rest, well, these two, if you need them, it's just a build-up of those two. If you have to work out any of, oh my gosh, any of these three, they'll be, the formula is given to you, so you don't have to remember those. But I'll send this out again today. Look, we've got a volume here. We've got some angles there, so I'll send this out again today. So the new people that have started in the last sort of couple of weeks, it's then back with them. But yeah, if what some people do is they remember a couple of ones that they're always got a little bit grey in their brain, and then as soon as they get to the exam, they write on a piece of paper. That's completely allowed, because we didn't take anything in with us. We took a blank piece of paper, we took a pen, and we've written down what we remembered or what we think we need to remember. So yes, that can be done, but I'll definitely send you the formula sheet, but it can't go in, and you won't get any, there's no other formulas you need. We don't need to know trigonometry, we don't need to know Pythagoras. There's nothing big that you need to remember other than what's on that piece of paper that I give you, and it's not even all that you need to remember. Right, so let's get back to shapes. Which is bigger? If we look at those three dimensions, 5 times 5 times 5. If it is non-calc, it is non-calc. 5 times 5 times 4. Without even working them out, we know it's going to be this one's bigger, because I'm timesing my 5 by 5, so I'm timesing my 25 by 5 and not by 4. So I can clearly see, without having to work it out, what the actual answer is. Okay, we know it's 125 or over 100, but we can see by looking at the dimensions that this one is going to be bigger, because we're timesing it by one more than the other one. So straight away we're saying A is bigger, because we can see the dimensions are bigger. When it comes to like 16 times 1 times 4 or 38 times 1 times 7, you'd get a calculator for those, and you'd be like, use a calculator. But for simple ones like that, they're not gonna, I don't see questions like that in the exam. I see volume questions, but generally, if it's a volume question like that, and again, we'll look at some of those another time, but it'll be Steve packs his fridge or freezer with tubs of ice cream that big. Work out the volume of your ice cream tub. He buys a new freezer. It could be A, B, or C. Which freezer will fit most ice cream tubs in? It's a case of you working out the volume of the little tub, the volume of the big tub, and see how many little tubs fit in the big tub. So again, it's process. It's looking at that same. One month in. It's looking at that same process of big tub, Could be a shipping container. We've had a shipping container. We've had a candle factory that's packing candles. We've had an ice cream tub. Generally, you get a big container and you've got to work out how many little containers fit in it. And that's the sort of volume question you're going to get. But if we look at question sorry, we're not three. What length of shelf would be necessary to hold 15 books of 2 centimeters wide? So it's not asking you, again here, it's not asking you to work out the volume, it's shapes. So we've got 15 books times by 2 centimeters wide. If you think about that, let's go 1. I'm not going to draw 15, believe me. Oh, 3, 4. So we're going to do times 15 times by 2 equals 30. And it doesn't say you need a space at the end. It doesn't say, you know, we have to have space between the books. It just says what length of shelf will be necessary to hold 15 books. So we're picking out 15 times by 2 is 30. And that question there will be probably more so aimed within a level 1 paper at non-calculator. If it was level 2, it'll be something else other than it, you know, Steve decides to go and buy 4 shelves. It costs him, you know, £15 for one piece of wood and 6p for a screw and 48p for a hinge. How much is it going? It'll add more onto it. Level 2 tends to create more of a story. Let's load question 4. Wayne is putting cupcakes. I like this one. Here we go. So it's not shipping containers. It's not ice creams. It's something else. Wayne is putting cupcakes into a box. Length 35 times by 7. Each cupcake is 7 centimeters long. So times table question. How many times does 7 go into 35? We know that that is 5. If we don't know it's 5, we can do our 7 times table, 7, 14, 21, 28, 35. Oh yeah, it's 5. So we can do it that way around. If it was a box that was 14 by 35, again, we'd work out how many fit in one row, which is 5, and then how many fit on the second row, which is 5, so it'd be 14 all together. So yes, some of those questions are like that. And then it might say, oh, actually, the box is 14 by 35, so we know how many fit on each layer, and then it's also 25 centimeters high. So how many layers can we get? So again, the level 2 builds a story for you. The level 1 is more straightforward. And the thing is about level 1, and if you progress on to level 2 afterwards, you'll get used to the wording, you'll get used to, you know, the telltale signs of what it's asking for you. So if people that are watching this are thinking, oh, these questions are too difficult because I'm only doing level 1, then these sort of questions absolutely will be in level 1. But yeah, the level 2 stuff that we're going to move on to, that's good practice, and getting used to the more lengthy questions. So like this one now, as a person that doesn't enjoy reading too much, I'm already thinking of this question, thinking, oh my God, where's the words? Where's the letters? Where's the numbers? What am I asking? What's it asking me for? So if you're like me and you read things really quickly, it's important that you read it a couple of times just to make sure you've not missed out of or all of or in. Right, so Gareth is moving house. He stacks DVD cases. That's a thing of the past. I've got boxes in my garage of DVDs from when I moved here 7 years ago that I've never got out of the box. Laid down on their largest surface inside a 70 centimeter tall box. So straight away, my box is 70 centimeters. I don't know how wide it is yet. Each DVD case has a height of 19 centimeters. Okay, so DVD 19. Right, so Gary, right, he stacks the cases laid down on their largest surface, so flat like that. Okay. Each DVD case has a height of 19 centimeters, length of 14, and a width. DVD case, oh, has a height of 19. And okay, so they've done their measurements a little bit different, haven't they? So they're saying DVD case. Now, I mean, he's got his measurements all to pot here, hasn't he? So it's saying 19. I'd say that's 19 high. I'd say that's 14 wide. And then this bit, you know, I'd say that's my depth. But they've got the measurements there, and we're saying that's 1.4. So they've written it in what I would say it's a little bit skewy language, but that's not a problem. Assuming there is only one box, only enough space left for one, and assuming there is only enough space left for one stack of DVDs, how many can he fit in the box? It's a calculator question. We're laying them flat. We've got 70 centimeters, and we're saying each DVD is 1.4 centimeters wide. So we're going to go 70 on our calculator divided by 1.4. I'm trying to think in my head, does 14 go into 70? Yes, it does 5 times. 70 divided by 14 is 5. What? Oh no, I'm dividing by 1.4. I'm thinking, so it's 50. I'm thinking they're big fat DVDs, that one. So 70 divided by 1.4 equals 50, not 5. I was thinking, that's what I'm saying. I often, when I'm dividing and timesing, I take out the decimal place and then put it back in. I just forgot to put it back in there. So it's 50 DVDs. And then for those of people that have still got DVDs, dust them off and watch one tonight. But if you're watching things on Netflix instead, then DVDs are staying in the garage like mine. Question 6. Wow, another one. Cassandra is stacking shampoo on the shelves of a shop. Given that each bottle of shampoo is Given that each bottle of shampoo is contained within a box of length and width of 6 centimeters and a height of 12.5. Okay, so she's saying each box of shampoo. And I'm not brilliant at drawing 3D, as you've already figured out. So we've got each box, so it's 6 and 6, and it's 12.5 high. How many boxes can she put on the shelf? Assume she can stack the boxes. So we've got and this is where the big box, little box fits in. So we can see here that we've got 6 along, and we can go up to 30. So how many 6s? Go into 30, so we can go 5 boxes. I can't really draw. I'll do it like that. 1, 2, 3, 4, 5. That is our 30. 20 going backwards. So how many rows can we put on? If we've still got to go 6, we can only go 6, 12, 18. So we can't get to 20 that way. We can still do 3. So we're going to go rows of 5, and then we can do 3 rows. So 5 times 3 equals 15. And then we've got stacking, and we were allowed to stack them. 12.5, it's 40. So again, you can use a calculator with pleasure, but if we go 12.5, add another 12.5, okay, we can see that's 25. And we had another 12.5. Can't fit it on now. We can see that's 37.5. Add another 12.5. We're over 40. We can't get out. We've only got 2.5 left, so we can't fit it in. So we know we can stack it up to 3. So we've got rows. We've got like literally layers of 15. Layers of 15. And we can do times 3 layers. So we've got 45 boxes of shampoo. Weird one, isn't it? Boxes. As you can see, I don't really use much shampoo, but I don't think it comes in boxes. It just comes in like, does it not just come in like tubes? Not tube, but yeah. And again, the making of questions, kind of believable, but it must be really expensive shampoo. It comes in a box and like, a container. Right, Jamelia is putting tennis balls into a tube like so. That doesn't need that bit at the end. Given the balls have a diameter of 4 centimeters and the tube has a height of 15 centimeters, how many tennis balls can she fit in a tube? Well, if we've got a tennis ball and it's got a diameter of 4, it's a sphere. So whichever way we look at it, it's going to be 4 centimeters wide. Doesn't matter. So if we can let's make it not square, as in like not 3D. We can go one ball is going to be 4. Second ball is going to be 4. Third ball is going to be 4. Fourth ball is going to be 4. Hang on a minute. We've got too much. We've got too much there. So we've got 8, 12, 16. It's only 15. So we can fit 3 balls in it. We try and fit a 4th one and the lid's going to come off. That sort of question, you might get in a level 2, but you might have to work out the diameter of the tennis ball first. So it might give you the radius or something like that, or it'll say, this is the radius of a tennis ball. Work out, diameter, we've got it already. And then how many tennis balls will fit into tube A, tube B, tube C, and it might give you that way. Okay, so we're looking at these questions. As much as they don't appear very often, when they do, these are often ones where people will be worth 1 mark, and it's a case of, oh, I didn't know how to name any shapes like that. Well, if we get these, and I'm not going to draw on here, but on paper. Okay, on the paper. If we look at those ones here, the ones that you might get mixed up are probably this one and this one, because we know that's a cube. All the sides are the same. Think of it as being a Rubik's Cube, or that program used to be on television, the cube. It's a square and a square and a square. All we can see. Tube of Pringles. Tube of Pringles is a cylinder. You can go tin of beans or you can go tin of soup, but Pringles are better. Pringles taste better. I can visualize Pringles now. I know it's a tube. I've got this one here. I'm looking at that one as a plank of wood I buy from the shop. And I'm looking at that one and thinking, right, it's not a cube because it's not all the sides are the same, but it's a square. So it's a cuboid. It's not a plain cube where all the sides are the same. So we've got yellow is a cuboid, orange is a cube, blue is a cylinder. We've got a ball. It's a sphere. Ball is a sphere. So what we've got left, we've got 2 pyramids left. We've got a square base and a triangular base. So that gives us a clue. It's based. We've got three faces, or we've got 4 faces. Square is so when you're looking at a square base one, oh my gosh, this is not going to be very good. That is rubbish. Oh my God, embarrassing. We've got a square-based pyramid. How do I do that 3D? I'm now determined. Right, so that's my square. That's my top. I'm going to go up to that one. Oh my gosh, up to that one, that one, and that one. Okay, so better than my first attempt. So I've got a square-based pyramid, and I think of that as being the pyramids. Think of the pyramids, and that's my square-based pyramid. Triangular pyramid, I'm not even going to attempt to try and draw on us, but not often going to get triangular pyramid coming up in your questions. If you do, it'll be work out the surface area, and it's a case of once you've got one triangle of your pyramid, times it by 4 because there's 4 faces. There's 3 that go around the outside and 1 at the bottom. Whereas a square-based pyramid, believe it or not, it's got 4 that go around it and 1 at the bottom. So that's a different one. That's times by 5, and you'd have a square as well as triangles. Okay, that is all the questions on that worksheet, and I'm not gonna stop there. I'm gonna write down what that worksheet was. That was called 3D shapes. Let me go to the top, 3D shapes, and then we're gonna jump straight into so let me see, that's 3D shapes. We're not gonna go like too complicated, but we're gonna look at plans and elevations. Something that on nets, I think it's nets. There's a question on one of the papers where it shows you something from above, and it's like it's not the plan, it's a net. So it's what it would look like if you unfolded it all. So let's have a look at these ones. Nets work. Let's go questions on nets, and it might be one question every other exam, but it's one question where, because the topic doesn't come up very often, doesn't mean to say it's not going to be in your exam. If you have a couple of attempts, then you're going to see a net question, or you're going to see a question to be 3D shapes. Sometimes, there's a big shapes is a huge topic, and so they can't give you one question on every little section of shapes. So if we look at that net, which 3D shape will the net come from? I can clearly see that every single shape on there is the same. He says drawing it completely not the same. So it's going to be a cube. A cube. So remember what we just did on the last one. We had to name that shape. So they're all the same. And we could see if we did that, if it didn't have that bit on the end, it's like a box without a lid. But the little extra bit here is just the lid. So that's the bit that goes on top. If we look at the next question, same thing. Don't know about anybody else, but if you suffer from hay fever, mine has started today. I've took my second antihistamine tablet, and I've not taken them since probably about last July. So I'm feeling a little bit sleepy. It's getting to me a little bit today. It's wow. Yeah, I get it early on in the year, so I get all that the tree pollen when the trees start budding and the flowers start first growing in the park, and so I don't suffer from grass pollen, but yeah, it's not good. Okay, so question 2. We're looking at that again. What shape is it going to come from? It's not a trick question because it doesn't have a bit sticking out there. If we made that shape, and I'm only thinking again chocolate, I'm thinking like of a box of chocolates. And that's not the best drawing I know, but that's a cuboid because it's basically a cube but different dimensions. So you can't call it a, I don't know, rectanguloid. It's a cuboid. So it's a cuboid. If we would to scroll down again, and the reason it's different to that one, look, is because that's got the flap there, that's got that one, but we could see that that'd go up the side, that'd be on top, and that'd go down the other side. So it's still going to be that shape. Is it going to give us a? Oh, here we go. Which one forms a cube? Which one of the following nets? So it's more than one. Okay, more than one. Can we fold these up and think which one would form a cube? I mean, I'm looking at those, right? So that one, does that one form? That one definitely does. No, it doesn't. No, that one. My God, my brain's right. Let's go back up to that one at the top. Right, so it's got 4 in a row and 1 out each side. 4 in a row. Right, so that one. Yeah, that one does, doesn't it? Because if you wrap those 4 around, that's your box shape, that's your bottom, and that's your lid. So that one does. So that means that one must do as well. Wrap it right round. That one can fall over. That one can fold up. Okay, so wow. Please shout out if you think I'm barking here, and I'm not talking like sense. I think because it's got that bit and that bit, I've got my 4 wraparounds. I can't even got a box to show you. And then I've got my lid. Eh? You can't. Did you just say you can't see or and see?
No, I said, what about C as well? I think
Yes,
C.
I agree. I thought you were going to say you can't see. I'm like, you've waited 27 minutes, tell me you can't see. Right. Yeah, I think C as well, because we go right round the little wrap, and then we got a lid and we've got a bottom. Okay. D, no. No, E, no. E, no. F, no. Okay, so it's 3 out of 6, so that's probably going to be the right. Going to give you the right ones. Again, it's recognizing and visualizing. I mean, I was about to start building a cube with my post-it notes, but I'm like, no, I can't do it. There's different shapes there. But yeah, those 3 would be the cube.
Which one's the
Right.
third?
A,
C, and
A, B, and C, because they've got little bits that stick out the bottom. Look, it doesn't matter which side they both stick out, because we'd still go fold, 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 and we'd go plop and then plop. I would be. I still think B would be. No.
No, I don't think so.
No,
Because
you can't, can you? No, because it'd be a fold on the bottom as well, wouldn't it?
Yeah.
Yeah. Yeah, A and C. I'm not even going to look at the answers, but yeah, you're right. We'd go round, 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 1 on top, 1 on bottom. If we did that one, we'd go round, 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 1 on the bottom, and yeah, that bit would also be on. It needed to be there, didn't it? So it doesn't matter. It wouldn't matter where it came on here. It could come there. It could come there. It could come there. But one has to be on the top, and one has to be on the bottom because then it has to fold in from the top. So yeah, you're right. I'm wrong. Okay, let's go down to number 3. Draw a net for this box. So when it comes to drawing nets, you'll be given a tool, and the tool is like a drag and drop tool or a pencil on the side of your screen. I will. There's a section on the NCFE website where you can test out the tools, and it's really worth having a go at those. So today I'm going to send out the revision guide again, and I'll send out the tool guide. It's just a link to the NCFE website where you can go in and have a play of the tools. It does make a difference if you've had a go with them before the assessment, because when you get to the assessment and you think that they don't work, but they actually do, then it can cause a couple of minutes kind of panic, or it can cause you to miss that question altogether. So having a go with the tools is really helpful. So we know, and I'm not going to draw this massively accurately. Okay, so I know that that's my lid here. So that's 3 centimeters long. I'm going to write my measurements inside, and that's 5. I've done my lid. Then I'm going down. Okay, so it's slightly smaller at 2, and yeah, it's still 5, but it's 2 now. Then I'm going to the bottom part of my box. That's meant to be the same size as the top part. Still 5 and 3, and I've got my lid on my other side. My other side is 2, and that's 5. So I've done all my kind of bigger parts, and then I have a bit that sticks out for my side, and I'm going to do both. I'm going to do them both at the same place. If you notice here, it's a different shape. So if I'm going to draw it on my 2 part, I've got to go 3 out. Okay, so that's 3. It's still 2. I'm going to do the same on this side. Okay, so that's my net. Those fold up like ears. My other 4 fall round, and it creates my net. It's not brilliant. It's not mathematically accurate, but you can get the understanding of what we're trying to draw there. Right, let's scroll down. It's asking me to do the same here. Draw a net for this group. So same again, exactly the same again. Yeah, I would, as much as up here it showed us different options, I'm always going to, oh my gosh, I've scrolled the wrong page. I'm always going to do the ears. I'm always going to do my bunny, not quite bunny ears, but I'm always going to do my ears that stick out the side. So think of it as being, right, I'm drawing my first shape. That's what I see when I look at it. I see this one. So now it's 5 along and it's 7 up. Then I'm going to do my bottom. So I can see that one is not, it's the same width, but it's not as long. Okay, so that's only 5.5. Then I'm going back up the back of it. I can see that one. Again, not brilliantly accurate. 7. Still all 5. They're all 5. And then I'm going down the other side again. So 5.5 and 5.5. 5. Now I've got 2 bunny ears. I need to do 2 ears. It doesn't matter where you put them. I could put them at the top. I could put them at the side. As long as if you remember you've put it on. If you've put it on one ear that's 5.5, I need to remember that I need to make it go. So I've got this bit, this bit, this bit. I need to make sure I've got the full 7 going outwards. It's going to be, it's wider, isn't it? So let's go here. We've got 7 here. We've got, so I want to go out here 5.5, and I'm going to go out 7. Right, 7. So that's the side of my box, and that's the other side of my box. Oh my gosh. Oh my God, we've got straight lines going on now. Oh, that looks good though. Hold your cursor on and you got 7. So that's this, oh my gosh, that's this side and that's the back side there. So we've got our ears, and we could call it a cross, can you back? It's ears are better. Link anything to animals and food, and we can't go far wrong. Match each net with the 3D shape. So this must be kind of like a similar question to what we did at the end of the last worksheet, in the fact that we've now got the net and the shape, so we've got to match them up. I'm going to do the ones that I'm going to do. Oh, there's another one. Okay, interesting. Yeah, I was looking for. I thought it was now 2 pyramids, but it hasn't. It's just got, yeah. So it's got a new shape. So we've got the square base pyramid. We said that's got the square, so we know that one. So on sheet, we'll put on sheet here. Tick and tick. We've got a cube because everything is the same. Tick and tick, and we've got 2 left here. If we look at the 2 that are left, okay, we've got 2 words: triangular and cylinder. Cylindrical but we're talking circles, triangle, we're talking triangles. In other words, a tent or a Toblerone, that's better. We've got a Toblerone is a triangular prism, and my square and my cylinder is my tube of Pringles every day of the week. My lids go on the top there, and that's my wrapper. So right at the start, I mentioned a packet of Rolos and try to find the surface area. So if I'd found out my area of that circle and the area of that circle, so I'll do pi r squared to find my area and my area, and times it by 2 because I've got 2, then I'd know if this wasn't measured here, which in a level 2 paper, it probably won't give you that measurement because it's trying to make you think it'll give you this measurement because you'll say, oh yeah, I need to tell, but it won't give you this measurement. But what that measurement is common with is the distance right around that circle. So you'll find that to find the area of your circle, so you've got pi times r squared, that equals area. So then you times that bit by 2 to get that bit and that bit. And then the other bit is pi times diameter. That equals your circumference. So, and that's what that will be exactly the same as the circumference of a circle. So I'd now know that measurement because it's my diameter and my circumference times by, it'll give you that measurement times by the height, for example. And that's going to give you that area in there. We've already got that area there because we've worked out the area of a circle. We've times it by 2, and so we'd have the surface area of our pyramid. Wow, what's it showing? Draw a net. Well, I don't want to say I'm not going to draw it, but I could just draw that. That is a square base pyramid. So my drawing is not brilliant at the best of times, but if I'm drawing number 7, it's going to be a square, and then I'm going out, 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 and out, and each one of those is 5, and each one of those is 7 when I go all the way around. So accurate drawing on the exam, you'll have squared paper, as in like it'll be a grid, and each square, unless it says otherwise, is 1. It doesn't normally say each square is like 10. Each square is worth 1 centimeter. If you're drawing like something to scale, it'll then tell you the scale. So it might say draw your garden, 1 centimeter equals 2 meters in your garden. So then you're looking at your drawing of your garden and shrinking it to that scale on the map. But there's another worksheet on scales as well. So the scale questions, again, don't appear every single exam, but when they do, it's normally an extension or somebody's running through the park, or a driver is setting off to the train station in his taxi and he's got to measure the distance. I mean, again, maps have been replaced by sat nav, even like on your driving test, which Miles did the other day, he didn't pass, but it's on. I didn't realize it's on sat nav. They tell you on a turn left, turn right. I'm like, what? So yeah, back in the day when you had your map on your lap and and your drink and your food, now you got to listen to the sat nav in your driving test. I've never heard anything as ridiculous in my life. It's like, right, question 8. Draw a net for that one. So triangular prism, again, we've got here, look, 1 square, 1 rectangle, 2 rectangles, 3 rectangles because it's a triangle, and then I've got 1 bit. Oh god, that's a bit rubbish, isn't it? 1 bit that sticks out there, 1 bit that sticks out there, and that's all you've got. Does it give us one up there? Does it give us one? Oh, they've done theirs in the middle. That's fine, absolutely fine. Right, next question. Oh, and then a net for that one. That's a tube of Pringles. Tube of Pringles, circle, square, circle. And that's our tube of Pringles. And obviously you'd label it and draw it to scale. Like you can't just freehand it like that. But what I would like to just do is go out of that one and see if there is. So we've got plans and elevations there. I wanted the question where you've got angles in 2D shapes. Don't think it's that one. Circles, area, perimeter, density, speed, no. Like the one where you got to find an area of a compound shape, so it's like squares that are stuck together. Because there is questions. Have a look if it is this one. It might not be the first couple of questions, but so if we just draw a line under that one. I know we're kind of digressing a little bit from shape, but a normal shape, squares, that's level one without a doubt. And again, the way I remember area is play area. So all the space inside the shape where I can play, and when I think of perimeter, not as nice as player, but I think of perimeter fence, and I think of prison. I don't know why prison, a prison perimeter fence, like the big high fence that goes right around the prison. So I think a perimeter fence is my area right around the outside, so I can't escape, and my play area is the bit I'm allowed to play in. And if we look at those there, they're all squares. So we've got 8 times 8, 2 times 2, 5 times 5. Definitely a level 1 standard question. So we're going to put 1 on the sheet for people. If they want to work them out, absolutely do so. Well, I'm looking for compound shapes. So the square below is 1 hectare in area. 1 hectare. Oh, what is? Well, I'm thinking right. It's told me the answer. What is 1 hectare in square meters? Well, we know to find the area. It's the length times the width. So it's 100 times by 100, which equals 10,000. And so again, it's non-calculator. But how did I do 100 times 100? Well, 1 times 1 equals 1. And I've got 1, 2, 3, 4 zeros. So literally that's how I did it. But maybe people know 100 times 100, that's just a number they know. It's 10,000. You could say 100 times 10 is 1,000. So then 10 times 1,000 is 10,000. But yeah, sometimes my simplicity doesn't astound me because I live with it. But yeah, 1 times 1 is 1, and I add my 4 zeros on the end, and I'm done. Next question would be how many hectares are in this? How many? Right, what is 1 hectare in square meters? Right, so that's the first question. How many hectares are in this square? So if 100 times 100 is 10,000, and that equals 1 hectare, 200 times 200, and you guessed it, I did 2 times 2, which is 4, and whack my zeros on the end. So it's 40,000. So if 10 equals 1, 40 definitely equals 4. So we can say question 2B is 4 hectares. I thought it was going to give me complicated shapes. Rectangles, same again, length times width, length times width, length times width. As you can see here, they've lifted the calculator a bit now, so we don't have, we're doing 4 times 3 in our head, and we're doing 9 times 5 in our head. Are we doing 40 times 26 in our head? Not necessarily, but if we did 10 times 26 at 260 and times that by 4, yeah, 1,040, then we don't need a calculator, but absolutely you can use a calculator. Let's scroll down. What is a shape where, you know what's being like, it's square here, a square there. That's not the one I wanted. Aha, here we go. So let's go question 5. So there was somebody messaged me this week saying, there's some of the measurements missing on one of my questions. I'm like, okay, which one? And it was something similar to this. And there is measurements missing. You're absolutely right. So if you're watching this back, you're absolutely right. There's no measurement for that part there. And there's no measurement for that part there. So how the heck am I supposed to work this out? Well, we're going to split it. So I'm going to draw it very badly. So I've got 5, and that's definitely not 5. And that's 18. That's not even really in there. That's 18. And that's 3, and that's 25. So what I'm going to do with this shape, I'm going to literally break it in 2. I'm going to go along here. Okay, because I know 25 times 3. I know those two. That's cool. 25 times 3 equals 75. I've done all that bit already. Don't even need to think about it. But now I've got a whole square that is not worked out, but I've still got my measurements for it. I've got 18 times 5. It tells me there. It says that's 18. It says that's 5. So I don't need to know what that is or what that is because I broke it in that way. So if we did 18 times 5, okay, and again, it is calculator, so we can use a calculator. But if we did 18.55, it's 19, and we add those two together, we're at 165. That's the easiest way to work it out. If you didn't see that, draw it again. If you didn't see it like that, and you might not have done, it's no big deal. We can work it out. So we didn't see that it was split like that. Okay, so we thought, oh my gosh, how am I going to split this? How am I going to split this shape up? Right, I'm now going to go down that way. Okay, so this makes things a little bit more complicated because we definitely have an 18, but we've now got something here. I can see 18 add my 3. So I've got 18 add 3 because that's that bit, and then that's that bit. So that's 3 as well, look. So 18 add 3 is 21. I still know it's 5. So now I'm okay. 23, 21 times 5. We've got 105. And then we've got this part here. I don't know what this bit is because that says it's 25 all the way along. Okay, so I've got 25 all the way along. I've got 5 of it there, so it leaves me 20. Okay, 20 there. I know it's 3 because it tells me my 3, so 20 times by 3 equals 60. Add them both together, 165. So we've got the same answer, but we did it 2 different ways. And how you see shapes is a visual thing, obviously. So how you see them is completely down to you. The first way, we split it without having to worry about what the non-measurements were. The second way, we tackled it like we didn't know what the measurements were, but we found them out and we still got the same answer. So I'd say this way, did it take us any longer? A few seconds, not much. Whereas this way was clean. We worked out the measurements straight away. Show 2 ways of splitting rectangles. Oh, that was the next question. We've done it already. And then find the area. Okay, we've done it backwards. We found the area of the shape twice. So we've done that. Well, we did that question, but we did it back to front. Is there another one like that? Please be another one like that. Okay, now it's showing us what we're doing. Brilliant. Right, we've got question 6. Find the area of these But I'm not saying it's give us the simple choice here, but it actually has split the shapes up for us. So we can see it's 2. Yeah, and we don't know that number there. But we know this one is 5, and we know that one is 9, and we know that one's 5. So this little bit, I can't draw there. I can't, is 4. So we know that little bit here is 8. Then we know that the other 2 is 5 times 7, 35. So that's 43. And with that question, it'd be important here. Look, remember with area, it's 2-dimensional. It's in centimeters, so it's squared. We worked out 2 dimensions, length times width. There's no height involved. It's a flat shape, so it's the 2 part there. Question B, a little bit different. It's split up, but obviously we've got 10 times 10 there equals 100. And we've got 7 and a 14 all the way along. 14 take away 10 is 4. So we've got 4 times 7 equals 28, 128. And this one's different. It's in millimeters and it's still squared. It's millimeter squared. Let me just literally close about to walk in. So can I blur my camera? Yeah, I can. Okay, so we've got 128 millimeters squared for B. And then part C. Same thing again, exactly the same process. It's split it for us. We've got 12 times 7, 84. And then we've got 11 times something. Okay, we know the full length is 12. We know that length is 9. 12 take away 9 is 3 equals 33. So we can see there we've got 110, 117. And that's centimeters. Sorry, I missed my centimeters squared. If you miss that bit off, and it doesn't give you on the electric bit at the bottom anyway on the exam, they won't give you that final mark. So if I just skip past that one, got 117, yeah, you've done all the math, great. You got 1 point for working out the math, but you didn't get your accuracy mark by giving them the right digits and the right sort of right measurements. Is these any more difficult? No, just because they've not put the line in for us doesn't make them any more difficult. Split it up how you see fit. So we'd go on. Were you going to speak? No? Sneezing? All right, 7. Let's not choose A because we just go 5. We'd split it down there. So we go 25, take away 5, so that'd be 20. 20 take away 3, so that's 20 there. So 26, sorry. So we just do 5 times by 26 for that part. And then we've got 20
26 or
left.
23.
Well, what?
5 by what? You said 26.
Yeah, because we've got 23 and then we've got the extra 3 here. So that measurement there is 26.
Okay.
Yeah, so we'd split it that way. So we'd have this part here to there. And then we'd go all the way along here. So we go 25, take away 5. So that'd be 20 times by 23. So that one will be 5 times 26. And then 23 times 25. And then add them both together. And you've got it there for that one. For these ones here, same thing. We've got the split. We've got to look at the 5. Can we go down there? Absolutely, yes, we can. So we're going to squeeze it into there. We can now see that it's 12. Add 3, add 3. So 12, add 3, add 3. That's 18. So that's 18 times by 5 for that square. Then we've got this one here. Okay, it's saying it's 15. It's saying that's 12. And then we'd have that bit there. So we'd add them both together. And that one's no different. That one is no different. We've got 6 by 6. And we've got, just because it's hanging off the end, then we've got 12 by 18. So that one is easier than the others because it's give you everything you need. I'm looking at any more difficult ones. A shape of a diagram square. I have a watch face written on a watch strap. So it's a square face. So that's giving you the clue there. It's a square face. So that bit will be 2 times by 2 for that middle part. 1 times 3 is 3. 1 times 3 is 3. So find the area. So it's find the area of the face. So it's a square, so it's 2 times 2. Find the area of the strap. 1 times 3, 1 times 3. So that's 6. Replacing the watch strap. So this is like a level 2 part. Replacing the watch strap costs £2.99 per square meter. How much change would you get? Okay, so let's go to that question, and that's quite a good one. Question 8. Right, so we can see that the face is 2 times 2, so that's 4. And then the strap is 1 times 3, 1 times 3, so that's 6. So we know the watch strap is 6. We need a new watch strap, and it's centimeters squared. Okay, the replacement watch strap, £2.99 per square centimeter. We've got 6, so we need to times that by 6. And then we need to know if we've got change out of a £20 note. I'm looking at that, and I'm hoping you guys are too. I'm looking at that and doing 6 times £3, which is 18, and then taking away 6p. 0.06p, so that's £17.94. If you're not seeing it like that and you use a calculator, just do 6 times £2.99, got it, and then take away that from £20. I'm not, again, if you see money questions and you think, oh, that's going to be really tricky because I've not got, I know I've got to borrow one, borrow one, borrow one, borrow one. Think of it as being money. Can I make that to £18? Absolutely. I've got 0.6, that makes it 18, and then I've got my 2. So once that's at 18, think about we replace that number with that number, and I'm doing all that, so I'll do 20 take away is 2. Or you might just know that if you had to pay £17.94 if you've done any bar work or shop work, that you just know it's £2.06p. It's a money question, isn't it? So we're going to get £2.06p. Change, make sure actually they don't like doing that. So in an exam, they don't like you doing, weirdly, the pounds and the pence. Don't know why. They just like you to say it's going to be £2.06. That's it. Or 206p if it's asking you in pence, which is a bit strange, but you know that's what exams they try and ask you for. Oh wow, this one looks cool. Right, so what we got here? Short side made from a central square and three identical. So no, it's not hard then, is it? I thought it was going to be like a real tricky one, but we know that's 15. It's a square. 15 times 15. Okay, 225. It's a calculator paper, so we can use a calculator. Then we've got 8 by 2. 8 times by 2 is 16. Times by 1, 2, 3. 48. Add them together. We got 2, 7, 3. So actually, find the area of the square part. 15 times 15. 2 points. That's definitely not a 2-point question. Find the area of one of the rectangles. 8 times 2. 16, and then find the area of the whole toy. We've done that. So that would be a 2-point question for just that part at the end. It wouldn't be a 6 marker asking you to do all those. It'd have that sort of shape, and it'd say find the area of the whole shape. So yeah, don't get too excited. You're not going to get points that easily in this exam. Right, we've got 5 minutes. We've got plenty of time. Can we do a triangle? Think of a triangle as being a square, but cut it in half. So if I'm going to go like that, oh gosh, it's not even a square, but it kind of is. Right, if I find out that's 6 and that's 4, okay, if I work out 6 times 4, that's 24, and then I split it in 2, divided by 2 equals 12, then I've found my triangle. It's literally the base times the height divided by 2. And the height is, I've split it into, so I picture it as, and again, you might think I'm bonkers. I don't picture that as a sail on a boat. I picture that as a square. Don't worry about that line in the middle, because I know that that's the height of my square or my shape. So I'm doing base 1 times 0.66, and I'm going to half it, because I've got to divide it by 2. And it's the same all the way down. We're going, it's the area, and it's still centimeters. Yes, centimeters. That's meters. That is more like a sailing boat. So we go base times by height divided by 2 for all of those. So what is that one? Question 10. All on sheet. We don't need to do the triangle ones. It's think of it as being a square. And find the area of the right angle here. Again, it's a square. I'm going base times height, so I'm going to go that way. Done. And then divide it by 2, divide it by 2. All the time, when it's got the right angle in there, it's always going to be divided by 2. Every triangle. We're going to go all the way down. Okay, so now we've got, so question 11 on sheet. 11 is on sheet. Same rule. Have we got those ones? Question 12. I can see we're getting triangles in. Oh, we've got circles involved there. Look at that one. Okay, so let's get 12. Let's get 12B. Let's go for 12B and then 12C. Have we got enough time? Here we have. Come on. 12B. Okay, I've got a length there of 9. It's this one here. Look right down there. And I've got a length there of 12. So 9 times 12 for my main part divided by 2. So 9 times 10 is 90. 9 times 2 is 18. So that's 108 divided by 2 is 54. So I know my main part here is 54. And I know that's 1 times by 9. 1 times 9. That's 9. So that's that part done. And I've got this little bit here, look. I've got 2 times by 1, that's there, divided by 2. 2 times 1 is 2, divided by 2 is 1. So my answer, I've quickly compartmentalized that as 3 different shapes. I've worked out the area of each shape, and I can see altogether it's 64. Do we have time? Whoa, we're cutting it shy. Let's have a look. 12C. Again, we've got 6 times 6. So we know it's 36. So we know where that bit's done. 36 in the middle. And then this one looks quite, it's not, well, we could say it's 2 semicircles, but when we've got two half circles, that's not going to be very good, is it? 2 half circles, we've literally got 1 circle. In 2. So we don't need to do we can just go to find out the radius. So we know what the radius is. So the diameter, sorry, not the radius. I'm talking about. We've got pi times by a diameter equals. What I am doing it wrong. Circumference. God, I'm doing it wrong. So pi times radius squared equals area. Oh, no, it's not me. Radius is half of the diameter. So diameter divided by 2 equals radius. 6 divided by 2 is 3. Let me scroll down. So we got radius squared, 3 times 3 equals 9. Times by pi, 3.14. Let's get a calculator. We should be able to do that, shouldn't we? 17, 20, it's 27. Oh my gosh, 27. No, let's just do it on a calculator. 27. I'm still thinking now. 27 at another 9.9, 27.9, 27, 28.26, 3.14 times 9. Yes. Sorry, I'm just challenging myself. It's the end of the day. I need to wake up, don't I? 28.26. 28.26 for my two circles. Add my 36 as a bit in the middle. And I've got 50, 60, 64.26. And with that fabulous end to the session, we've done some shapes today. Please, again, if you're watching this on catch up or you're watching it now, you want me to do any particular topic, just send me a text, send me an email, tell me what topics you want to cover, and we will start at 10 o'clock on Monday with a new topic. Looking forward to seeing everybody then. Let me just stop the recording and